You type a name, like example.com, and a website appears. But computers do not talk in names, they talk in numbers, IP addresses. So something has to translate the name into the number, in the blink of an eye, before the page can even start loading. That something is DNS. Let's decode it. I'm Tessa, and this is Envision Decoded. DNS, the domain name system, is the phonebook of the internet. You give it a human name, like example.com, and it gives you back the machine address, like 203.0.113.5. Without it, you would have to memorize a string of numbers for every site you visit. DNS is the quiet lookup that happens behind every single click. Why not just use the numbers directly? Because names are easy to remember and numbers are not. And because the address behind a name can change at any time. The site can move to a new server, and as long as DNS is updated, you never notice. The name stays the same while the number underneath is free to change. That separation is what keeps the web flexible. So what actually happens when you ask for example.com? Follow the journey. First, the cache check. Before anyone goes anywhere, your browser and your operating system check their own memory. If they looked up this name recently, the answer is already there, and the whole process stops in a millisecond. If it is not cached, your computer hands the question to a recursive resolver, usually run by your internet provider or a public service. Think of the resolver as a helpful librarian who will go and find the answer for you. It does all the running around, so your computer does not have to. The resolver starts at the top with a root server. The root does not know the address of example.com, but it knows who handles .com. So it replies, "Do not ask me, ask the .com servers," and points the resolver in the right direction. Next, the resolver asks one of those TLD servers, the ones in charge of .com. The TLD server does not know the final address either, but it knows which name servers are authoritative for example.com, so it hands back that pointer. Finally, the resolver reaches the authoritative server, the one that truly holds the records for example.com. It answers with the actual address, the A record, 203.0.113.5. The resolver caches that answer for next time, governed by a timer called the TTL, and hands the address back to your computer. Now the page can load. So, to decode it, DNS turns a name into an IP address. Your browser and OS check their cache first. If it is not there, a recursive resolver does the legwork. It asks a root server, which points to the TLD, which points to the authoritative server, which returns the real address. The answer is cached for the length of the TTL, so the next visit is instant. If DNS finally clicked, hit subscribe so the next one finds you, and a like genuinely helps. Next time, we answer a question hiding in this one. How did your computer get its own IP address in the first place? That is DHCP. I'm Tessa, this was Envision Decoded. See you in the next one.